Hello everyone, my name is Suraj Kharage. I am Senior Staff SD at Enterprise DB, working since last 10 years as a database developer for PostgreSQL and ADB's proprietary advanced server. Today's topic for the discussion is PostgreSQL catalogs. There are many instances where we need to find more information about the issue that we are facing with the PostgreSQL. And these four are the most common areas where we should look for. First thing we check for is database logs to get more information about the issue that we are facing. If the issue is related to the configuration settings, then we check for the configuration file. Sometimes we need to take the help from the OS tools. And the last one is ask the PostgreSQL itself. System catalogs are there in PostgreSQL, using which we can get the information about the PostgreSQL and how it is running. System catalogs consist of system tables, system views, and system functions. In this talk, we will be focusing on the system tables. The system catalogs gets created during the cluster initialization. The system objects stored in a special schema called PG catalog, and it's always in your path. If you don't specify PG catalog in your search path, then Postgres internally adds that path as the first schema in your search path. If you specify PG catalog in your search path, then that follows the schema order. You can list down the system objects using psql meta commands. For example, to list down the functions, we can use /tf command of psql, right? And if you want to list down system functions, then you just need to add capital S to the meta command. That is /dfs will show you the system functions. Alternately, you can also use the regex expression /tf space pg underscore star that will list down all the objects. Those are starts with pg underscore. Most of the SQL or catalog objects are start with pg underscore. System catalogs are designed in a such way that their performance should be faster because those are extensively used by a system. Sometimes a simple select command may need to look up into the multiple system catalogs to complete its operation. Internally, Postgres catalogs are implemented and cached in shared memory to get better performance. User generally refers objects by name, but PostgreSQL internally refers objects by OID. OID is a unique object identifier which gets assigned to every object at the creation time. OID is a 4 bytes in size. It's always convenient to compare OID instead of names, right? Because OID is a 4 byte size and names could be up to 64 bytes. Also, comparing the names also doesn't work anyway because you have the object name same in the different schema. Right? For example, we can create the table, same table T1 in schema S1 and S2 as well. So that is why comparing, but those two tables could have a different OID, right? And similarly, operator and functions can be overloaded. So I have shown you one of the example of the system catalog. I have used /ts command to show how the system catalog looks like. That is pg underscore tablespace, which stores the information about the tablespace. It is stored in a pg catalog, right? As I mentioned previously. The system catalog has 5 columns. First one is the OID, which is the OID of the tablespace. Second one is the tablespace name. That is the name of the tablespace that we provided in a create tablespace command. Third one is the tablespace owner, SPC owner. The type of this column is OID. As I mentioned previously, we internally stores the objects as a OID, right? And this is the OID of the tablespace owner. And the corresponding entry is in PG auth ID. PG auth ID stores the information about the users and roles. So that OID maps here in PG, that is as a tablespace owner. Fourth column is the tablespace ACLs. Those are privileges for the table spaces, and the table space options that we provided during the create table space command. It has two indexes. One is on the OID column and second one is on the name column. And the table space for this PG table space is PG global, which stores the all the objects which are shared catalogs. We will see in the further discussions like what is those shared catalogs. Right? Most SQL objects are represented internally by a row in a system catalogs. As I mentioned previously, if you create the table space using create table space command, then the corresponding entry gets stored into the pg_table space system catalogs. Right. In some cases, the catalog name doesn't match with the SQL object. For example, let's take an example of a pgauthid catalog that stores the information about the users and roles. Here, object name is role or user, but the catalog name is pgauthid. So in some cases, that catalog doesn't match with the object name. That is by design. In some cases, there are additional rows in other catalogs. If you create the table, then the multiple entries go into the different catalogs. I will explain that later in the presentation how that works. We can create n number of database in a single database cluster, right? And each database has its own copy of system catalogs. But there are some shared catalogs as well, which store the information about the global objects such as user, table spaces, database, etc. And those shared catalogs are common to all databases. So that means those shared catalogs are not per database, but those are per cluster which stores the information of the global objects. For example, pgauthid, PG table space, as I mentioned earlier, we store the information about the users and table spaces respectively. So I have listed few of the shared catalogs here. pgauthid, which stores the information about the roles and users, as I mentioned previously. pgauth members is another shared catalog. We store the membership between the users. And the pgdb role setting stores the information about the DB and the role level GUCs. For databases, we have a PG database. For table spaces, we store the information about the table spaces. Dependency comments and label on shared objects, such as user, table spaces, and databases, are stored in these respective shared catalogs. Replication related catalogs are also shared catalogs. Those are shared across all databases. I have listed few of the system catalogs, which are basically non-shared. PG class, we store the information about the tables, view, indexes, foreign tables, and those are distinguished by the rel kind. Rel kind is one of the column of the PG class. We distinguish what different kind of objects are stored in a PG class. PG attribute, we store the information about the columns of the relations or tables. Again, this is the one of the example that the object name doesn't match with the catalog name. PG namespace, store the information about the schema. PG type, PG constraint, PG index, and PG operator, those are self-explanatory catalog tables. We store the object of these types, constraint, and indexes operators respectively. Again, here are few more system objects, system catalogs. pgproc, which stores the information about the functions as well as procedure. Dependencies are getting stored inside the pgdepend catalog. If you create any extension, then that information gets stored into the PG extension. PG language, PG cast, and PG trigger. Again, those are self-explanatory catalog tables. There are more system catalogs exist in the PostgreSQL, and you can find more information about them in PostgreSQL documentation. PostgreSQL provides object identifier types, which basically simplified the lookup of OID values for object. These are we just need to cast these types to an object name or the OID, and that will do a lookup for the objects. right? This is for the simplicity. And those object identifier starts with the reg, right? I have uh, given two queries in this slide. First one is using the object identifier types, and second one is without object identifier types. For example, if you want to list all the columns which one particular table has, then my query looks like with the object identifier type is select star from PG attribute, where attribute rel ID is equal to my table, cast operator, and then reg class. Reg class is a object identifier type to find out the objects for class, or we can say tables. So this will list down all the columns that exist for a table called my table. The second query is without object identifier type. Of course, it is using a subquery. It has a subquery basically. First, it will find the OID of that my table from a PG class, and then that pass OID to a PG attribute uh, catalog table to find out all the columns that table has. So in short, the object identifier types makes our object uh, search simplified. So I have mentioned few of the object identifier types here. For relations, we have a reg class. For types, when we have a reg type. For schemas, we have a reg namespace. For user collisions, the name is self-explanatory, reg role and reg collision. For functions, we provide two object identifier types. One is reg proc and reg procedure. If you know the function name only, then use the reg proc. If you know the function and their parameters as well, to find out the exact match, then use the reg procedure. Similarly, for the operator, reg OPR is used if you know the operator name only. If you know the operator name plus its argument, then use the reg operator. For database, we have a reg database that is latest addition in a PostgreSQL 19 that is committed, but it is not released yet. This is just for your information. Now we will see one example here. If you create a table, then how corresponding entries get stored into the multiple catalogs, right? PG class is there which stores the one row per relations and stores the information about the relations. PG attributes which stores the information about the column and one row per column. Similarly, PG index store information about the indexes on the table. PG attr diff will store the information about the default expressions. PG constraint store the information about the constraint that we have on the table. Now in this slide, we are creating one table that is called foo, which has basically three columns, C1, C2, and C3. C1 is of type integer and it has a primary key. C2 is of type varchar 10 and it has a not null constraint. C3 is of a Boolean type and we have set the default value as false to that. And we have used fill factor 90 as a real options and the table space that is PG defaults, that is means database default table space. Now with this, I have tried to show you the details that get stored into the PG class. This is the example for the PG class for the relation that we have just created called foo. If you see the result, then rel kind is R, that is for the relations. If you have a view, then rel kind would be the V. If you have a sequence, the rel kind would be the S. If you have a table, then rel kind would be the F. Rel namespace is 2200. That is again a OID of a schema in which this foo table resides. The mapping is based on OID here. Rel table space 0, that means it is using database default table space. Rel pages are 0 since we haven't created any data in this table. Rel tuples are initialized to -1 initially. Rel 0, again, this is the owner of this relation and we have stored 10 as an OID of that user. That is again mapped to a PG auth ID entry. Rel file mode, that is the physical file name of this relation which exists on a disk. Rel n-att, number of attributes for this relation, though that is 3. Rel SL is blank here because we we haven't assigned any privileges to this relation yet. Real options as mentioned in the grade table command, fill factor 90. The next catalog we can see PG attribute, which stores the information about the columns, right? Then for the same table, we can check the PG attribute and we can see the details of the columns that a foo table has. If you see I have used the same query here as well. Now I am just scanning through the PG attribute for this particular relation, that is foo. Initially, you can see -6 to -1 entity numbers are there. Those are system columns and their details. Entity number 1, 2, 3, those are user-defined columns C1, C2, and C3. In the third column, you can see ATT type PID. That is means their type. For C1, we have a C3. Again, that will be a map to a PG type for C1 is declared as a integer. 1043 is a OID for the varchar, and 16 that is 16 OID for the boolean, as we declared above. Right. If the attribute is not null, then it is marked as true for C1 and C2. Primary key is by default is not null. So for C1 and C2, we can see attribute not null as a true, and for CT, we don't assign any not null, so that is false. Now, next catalog we can see is PG index, right? For the same command and for the same relation foo, we can see how the PG index gets populated after creating the table foo. Like first column is index and ATTs, number of attributes for the index. Since we have a primary key, it has a unique index on the same, right? So n number of attributes is 1. Is index is unique, right? Index is unique as well because it is a primary key. So that is again true. Index is primary. Yes, that is again true. Index key, that which column is on which this index is on, right? So index key is 1. Yeah, so these are details about the PG index. Now next catalog is PG ATTR diff, that stores the default expression information of the relations, right? And the first column that we fetch is OID, that is the OID of this default expression. Add rel ID, that is the relation ID of this default expression, right? 24628. That is the OID of this foo relation. ADNum, that is again attribute default attribute number, that is 3, because we have a default expression on a column 3, that is C3. And here I have used pgget expression system function to display the expression in a user readable format, and that is why you can see pgget expression that is false. That is all about PG ATTR default. Now we will see how PG constraint gets populated with this table, right? Constraint will store the information about the constraints of that table. We can see 3 rows populated for the table foo. First 2 entries are for not null, and the second one and third entry is for the primary key, right? This is the new addition to the Postgres 18, that now PG constraint can show the entries for the not null constraint. Thanks to my colleague Alvaro, who has worked on this feature in a Postgres community, and now we can see for not null constraint, we can see entry in a PG constraint. Yes. Now, corruption is bad, and it can behave abnormally once the correction occurs in our database, right? The queries that gives the unexpected results. There are causes for these corruptions, that is bad hardware, bad software, or maybe because of user errors, that user might accidentally deleted entry from the catalogs, and that may lead into the catalog corruption. I have listed few of the examples here just to show that the catalog corruption looks like this. User may experience these kind of errors if there is a catalog corruptions, right? Cache lookup failed. This is the most common error. And if you hit that error, that means there is catalog corruption at your end. And recently we found that one of the example for the catalog corruption and while taking the PG dump. So this is the third example that I have put over here. And this is for breaking the FDW things, right? We have a foreign, we don't have an entry for the foreign server, but we have a respective entries for the user mapping and the foreign tables. So the basically the catalog corruption looks like this only while taking the dump. So basically how we can uh, detect this catalog corruption and fix these catalog corruptions, right? That is the question here. Enterprise DB provides PGCat check extension that is a open source. We can use that with the Postgres. Uh, how we can use that? Just use that binary with the data by providing the database name, and it will scan your all the catalog system catalogs and come up with the list if there is any catalog corruptions. So for the PG dump error that I have mentioned in my previous slide, the PG cat check shows the output looks like it has the user mapping for the server, but no matching entry in the PG foreign server, right? And similarly, we have a entry for foreign table for the server, but the respective foreign server entry doesn't exist. So the output looks like this only. Then basically we can, if you know how we can recover this from the backup, then that would be good. Or basically we sometimes we need to delete this stale or delete this orphan entries from the database to make the database consistent and then restore back from the previous valid backup. This is how we can handle the database corruption, catalog corruption. So for preparing this talk, I have taken some help from these links, basically. Thank you so much for attending this session, even this virtual session. I know it's hard, but thanks. I hope you have gained some knowledge in these regards. If you have any questions for this, then please reach out to me on my email address, surajkharage@gmail.com. Thank you.